Hello, this is Mike, and welcome back to another in the ongoing Godot tutorial series. Today we're going to be taking a look at 3D. So we're finally going to move on to the world of 3D development using the Godot engine. As always with all of these tutorials, I'm going to assume that you've gone through all the previous ones, or at least understand what were covered in them, so there will be no backtracking. So I will assume anything that I talk about in the past, you already understand. So if I do go over something you don't get, probably check the previous tutorials, and no doubt the answer will be there. If it's still not, that means I screwed something up. Let me know, and I will address it somehow, at least, very least in the comments. There's a text version to go along with this particular tutorial. It'll be linked below. It covers pretty much the same information. On that topic, what we're going to cover today is pretty much the basics of 3D. We're going to create our first 3D scene, very simple, very straightforward, and then in the next tutorial we'll be looking at bringing in 3D models, animation, and all that jazz. But there's enough to cover on 3D to make its own tutorial. Now, if I sound a little weird to you, sadly I'm suffering a bit of a head cold, so I may have to pause a couple times while I go into a hacking fit, but I'll try to make it through this thing. Regardless, let's jump back into Godot. Here you see I'm starting up a new project, and let's just fire that off. Open it up, and let's fire up Godot. Now, if you've been working in Godot on the 2D series up till now, every time you've loaded up Godot, you've been thrown into the 3D section and then had to switch to 2D. As you see right up here, our default view right here is a 3D view. Godot is a full 2D and 3D engine. It has the ability to mix and match between the both. We'll cover that as an advanced topic a little bit down the road. But now we're looking at the 3D side of things, and it's very, very, very similar to the 2D side of things. But there are some very key differences, more so than just having one extra dimension. But for the most part, that is actually the biggest difference. Same sort of scene layout you had when you worked with 2D. So I'm going to start that straight away. What I'm going to do here is just create a node as my parent class. And I'll set up the rest of this stuff so that I don't have to do this later on. We've done this in every single tutorial so far, so, oops. You think I wouldn't screw it up, but I did. I forgot to save first. This should all be familiar to you at this point. So, save our scene. Set it as the startup scene. Like so. And done. Okay, so the big difference is, obviously, we're going to work in this 3D panel as opposed to this 2D panel. And your 3D panel has some differences. The first off is this guy in the top corner says top perspective. We'll get back to that in a second. Here's our scene node. And the biggest thing is, while we were working in 2D, 2D nodes were all inherited from canvas item. 3D nodes all inherit from spatial. So this guy right here is the base class of all of your various 3D nodes. And you'll see there's a lot of overlap. Classes that exist in 2D also have a 3D version and vice versa. A lot of times the 2D version will have 2D postfix at the end, so you've got camera and camera 2D. Now, it's very important to realize these cannot be easily intermingled. So if you've got a 3D world, you need a 3D camera. 2D world, you need a 2D camera, etc. So spatial is your base class for all of your various 3D entities. And you'll notice here you've got the visual ones here, collision ones right here. You have your camera classes, joints, and then some specialist stuff. We probably touch on some of these very far down the road. But for right now, we're focusing mostly on these visual instances and then eventually on this camera. So a visual instance is basically something that is in 3D that will be displayed. Now, one of the downsides of the Godot engine, there's not a lot of primitives built in. A lot of game engines, you basically can easily drop in a quad, cube, sphere, torus, teapot, etc. In Godot right now, there's a known issue, open issue, so it might come in the future, but right now all you can do and start with is a test cube. Now, as I said, we're going to cover importing and using 3D models in the next tutorial. So what we need is just some geometry to show, and that's what a test cube is very handy for. So let's go ahead and create one, and then boom, there it is. That's a test cube. It's basically a color pattern, texture 3D cube that you can start and play with. It's created about the origin in your scene by default. And now we're going to stop and talk for a moment about the actual 3D scene, the 3D navigation that's going on here. As you see right here, there's these lines right here, both in, well, they're in green right now, which is a little confusing, but those are your axis indicators once we get off of this view. Now, I said earlier right here, this top left corner here shows this is not in the 2D, and this is your perspective. Bad choice of words, because perspective is used twice. This is your eye in the 3D world. So in this case, we're viewing from the top. We can also search from the bottom, left, right, front, and back. And as you saw, there's a corresponding number to go with each one. And you're seeing some of the default lighting in the scenes, but that's just the scene adding that for you. You can actually turn that off using View, turn off default light, like so. We'll turn that back on for now. And that's just a faked lighting in the scene, so you can sort of see how things are without having any lights placed. We'll cover off lights in a few minutes. There are some things you can set for your geography down here. For example, you can turn it so it's visible or not visible. You can modify the material attached to it. Does it receive or cast shadows? Billboarding, which is kind of an advanced topic. We'll touch on that later on. Baked lighting, etc. Again, a lot of those are sort of advanced topics, things that we'll talk about later, beyond what we want to deal with here. All right, you guys are being annoying. All right, so that's a basic 3D view, and you can switch between them, as I said, up in the top left corner. However, what you're going to want to do a lot of times is deal with more than one view at a time. And in your view menu, you can actually set it up so you can have multiple views. So let me press here for 4 viewports, or you can hit Control plus 4. And now you'll see it's split. Now they're all using the same perspective, and obviously you're going to want to change. I got to stop using the word perspective, that's confusing. They're all using the same camera angle, and you can change that on each one. So example, we could have this one at the bottom, this one at the right, and this one at the front, for example. So you have your multiple different views. Now, in a particular view, and I'll go back to full screen for this. So again, view, and then one viewport. You can also, using your middle mouse button, if you just hold it down, so I've got the middle mouse button held down right now, and if I move left or right, up or down, the camera moves around. So we're basically moving our camera around the origin here. You can change the behavior for this. This is called orbit in the settings, so how it actually handles when rotating around the view can be changed in the settings. We'll look at that in a second. But next up, you've got your scroll wheel for in and out for zooming. Finally, if you hold down the Shift key and the middle mouse button, you can pan the camera around, or your perspective around, so it's not technically a camera. So you can have this free-flowing view of the world that you're dealing with. Now next up, you've got your modifiers. And your modifiers work a lot like in 2D, but there is an additional axis attached. And I guess I should cover on that quickly, because there is one important thing to know about Godot, or any game engine you're going to work with, and that is what the up axis is. In other words, what axis of orientation determines what is up and down in the world versus in and out or left and right. And in this case, the up and down, the up axis is the y axis. This green axis right here is up and down, and that represents your y coordinate. Your x axis right here is your left and right. So if I go back to the front, it's a little bit more telling. So see, left and right, up and down, and then your virtual is if you could reach your hand into or out of the screen, that is your z-axis. Now, different 3D modeling tools use different axis of orientation. Blender is, I believe, yes, Blender is a y-up axis, whereas 3D Studios Max, due to its architectural background, is actually a Z-up. So Y is into the screen and out of the screen. I find Y-up more intuitive personally, but there seems to be about a 50-50 split between game engines and game tools, which one they pick. Now nicely, you can rotate between you can just rotate by 90 degrees across one axis and have a Y-up become a Z-up. So it's not a huge deal, but it's one of the things to be aware of. So when you bring your models or your assets in from another tool, they could essentially be rotated and off the axis that you particularly thought they were. Plus, obviously, it's going to affect your game logic, your code. You're going to want to know, what in and out versus up and down are. So when dealing with Godot, up is Y. And again, Y is green, red is X, blue is Z. And that's pretty standard across all of that color scheme is, I know Blender and Maya both follow that particular color scheme, so at least that's consistent across all the tools. Okay, so that's a little bit on the orientation. Now we're going to talk about their translation tools. So we've got, translation tools. So we've got the move tool, the rotate tool, and the scale tool. Now when you're dealing with 3D objects, it's a little bit different. So let's have our cube selected here, and you'll see we have this widget now. This widget allows you to orientate along the 3 different axes. Again, the same color codes. Red, X, Y is green, and Z is blue. So you can pick on an individual axis and then modify on that one only. So for example, here is up and down, left and right, in and out. Or you can pick somewhere in the middle and transform freely. Same across all of the widgets. So your rotate shows one color for each particular axis. So your red is, I'm rotating around this axis here by doing so, or around the z-axis by using blue, or the y-axis by using green. This would technically be yaw, pitch, and roll, but we won't get into any of that. So those are your three different rotation colors. Each one corresponds with the corresponding axis. So it's very consistent, and then scaling works exactly the same way, if it works at all. All right, where's my scaling widget? All right, there's no widget. Interesting. So that is the basics of what you need to know here. It could be that that cube doesn't allow non-uniform translations, so there wasn't a scaling widget there. I'm not sure what just happened, to be honest. But those are your three primary movements, just like you dealt with in 2D, but obviously there's a third coordinate, so this widget is very important. Now, I said earlier there are some settings you can configure on this, and let's get into that right now. So come up here to the top right, there's settings here, and go on to editor settings. And you come down here to 3D editor, and there's a couple of key things you can set here. You can change the way that it zoom and orbit work, or you can change the shift key for pan or orbiting, or zooming. Sorry, I actually only showed you using the scroll wheel, but if you hold down the control button and middle mouse button, combination will also zoom. So, but you can also change the size of that the manipulator, or you can also change the opacity of it, so how strongly it will show. So there's a number of settings you can change here. Also, if you come from a different program, you can actually set it to use the navigation scheme from Maya or Modo. So if either of those tools is what you're used to, you can configure it to change right there. Obviously, it's going to change any of the hotkeys that are listed, or some from the previous tutorials, but then if you are from one of these backgrounds, you should know what the replacements are, and it should make sense to you. So if your preference is to use either of those schemes, you can change it under this navigation scheme right here. Just close that out. Okay, so that's the basics of the overview. So right now, we have a world with a cube in it. And if I go ahead and I run this, nothing happens. There's a couple catches here. Unlike in the 2D world, there's no default 3D, there's no default camera at work here. So to render your scene, you need to have a camera. You need to have at least one camera. So now we'll go ahead and look at adding that. So just come in, click a new node, and they're all called camera. So basically, it's inherited from spatial, and it's called camera. Now, there's this other one down here called interpolated camera. The name is slightly misleading. It's more of like if you're from a photography background, the interpolated camera is more like a swing arm. It's for controlling smooth and relative motions, and it's beyond what we're going to talk about here. But ultimately, what you want here is a camera. And note, not camera 2D. They're not interchangeable. So all you have to do is add a camera to your scene, and you'll see right away it got positioned around the origin just like our cube here. Let's just go ahead and move it across the z-axis. So you can see it's changing along the z-axis over here. That's perfect. That's exactly what we want to do. So now that we have this camera in the world, you'll notice we have this preview button showed up right here. And let's go back to a split view instead. So 2 viewports. So what we can do now, so we've got our normal viewport here for modifying our scene, the one we just had, our perspective viewport that we can freely modify and move around in. That's really confusing. Or I can obviously quickly snap back to any of the defaults, such as front. So we can move things here, but what we'll do here is set this into preview mode. And essentially what this view now does is shows what this camera is currently seeing. So let's move it up a bit, and you'll notice the cube comes better into view. So this is just us positioning the camera in 3-dimensional space, like so. Now, there's a couple of key aspects to be aware of when dealing with the camera, and they're all down here in your in the inspector properties for the camera itself. Now, obviously, it is a spatial, so it inherits the basic traits, which basically is a position and visibility from the spatial class. But on top of that, it's got a couple more that are important. First is your camera type. You have 2 types of cameras. You have a perspective camera and an orthogonal camera. What that really means is as something gets further away along the z-axis, so as it disappears into space, With a perspective camera, it mimics the way the eye works, and that is it draws that edge smaller. Whereas an orthogonal camera, as it gets further away, it draws it the exact same size. So let's look at this edge, for example. This is further away in the scene than this edge, at least virtually as we're seeing it. So if we switch over here to a perspective camera, it does nothing. Is it not up? Oops. Oh, okay, it's not going to keep the settings as nicely as I wanted to. But basically, that edge would become exactly the same size. It's easier to illustrate in a package like Blender. So this would actually be more rendered probably out to about here. So that's the effect of the orthogonal versus the perspective. Now, the reality is, there's a very simple way to think about this. Most of the time, 95 times out of 100, if you're making a 3D game, you want a perspective camera, period. If you're making a 2D game, 95 times out of 100, you want an orthogonal camera. So, because a lot of times in a 2D game, even if you're working in 3D, you're dealing with quads that are all, they don't get smaller as they get further back. They're just layered on top of each other. So you don't want the illusion of depth being created, whereas in 3D you do. So you pick a perspective camera. So those are your two camera types. Most of you will stay totally with the perspective. Now next up is the field of view Y. And you can think of this as the number of degrees from your nose that you can view. So saying field of view of 90, as this setting says, means you can see 45 degrees to the left of you and 45 degrees to the right of you. So as an extreme example, if you're standing there right now and you put your arms out to your side so they're straight out, so 180 degrees from hand to hand, you can just, or for most part, from your peripheral vision, see both hands. This is a 180 degree field of view. And the reality is, most humans have 170 to 180 degrees as their proper field of view. But the focus point, if you take peripheral vision out of it, it's much narrower. So this is the value that's set. And this is the cone, or well, it's called a viewing frustrum. But that is what determines the angle that you can, the amount in front of you, the degrees of a triangle that is visible centered around your nose. And default values sort of depend on what your target is. If you're dealing with a screen that's quite close to you, a value of 80 to 90 works, 70, 80, 90 type thing. So that's your, a lot of computer games, because you sit quite close to your monitor, will have a higher field of view. Now, if you've got it on your couch, however, so most console games have more like a 60 or a 70 as their field of view. Now, several games allow you to actually modify this, which is a very good thing to present, actually, because myself, for example, if a game has a wonky field of view, especially for the third-person over-the-shoulder camera, it makes me want to throw up. So if you want to give your user the ability to set this field of view value, myself as a personal user, I appreciate that. Anyways, next up, you've got near and far frustrum. And this is actually just how close and how far your camera will record. So at 0.01, things that are 0.01 in front, so like basically right there, will be recorded by the camera. That's where the camera starts seeing things. And the far view goes together to determine how far out it will. And basically all these things, so the field of view, the aspect ratio, and the projection, and the near and far plane, all to go together, and they make this basically something called a viewing frustrum, which you can think of as 3D triangle, or 3D, I don't remember the name of the word, but like a pyramid type view of what is visible by your camera. So those things all go together to make that, and that's for the most part the most important parts of these settings. Field of view obviously is going to change based off the device and the type of thing you are targeting, but as I mentioned earlier, you probably want to make it user configurable if you are willing. Now, if I'll show you, I don't know how immediately it'll update, but let's switch this down to a 60, and you'll see with this preview the result. See, a lot less visible within this viewing frustrum, and this yellow line here actually represents the outer limits of what the camera can actually see. So the field of view does have a profound effect on how much is visible to a particular camera, but it's going to ultimately be up to you to determine what is right for your particular game. There's tons of topics on ideal camera, ideal aspect ratios, etc., way beyond what we're going to cover today. So just so you know that. So anyways, now that we have a camera in our scene, let's go ahead and run it. And okay, so we're kind of getting there, but we're a little bleak and dreary here. And that's just because we don't have a light yet. Very simple again. It's inherited from spatial. Just create a new node. It's a light. Now, ignore the baked lights exist for now. That's an optimization trick. So basically, to take lights and turn them into textures. We're not going to cover that for right now. Instead, we're going to focus on these three. Now, once again, there are 2D versions, not interchangeable. So those are completely separate. Pretend anything that inherits from canvas item, for the most part, doesn't exist while working in 3D. Okay, now there are some exceptions to that, but they are exactly that, exceptions. So that leaves us three different kinds of lights here. There's a directional light, an omni light, and a spotlight. Each one kind of serves a different purpose. A spotlight is like a directional light, a very focused sized beam that has a set range. Now you can think of a spotlight, the most direct examples, well other than obviously a spotlight, are probably like a handheld torch or flashlight, or the headlights on a car. They're a set beam that goes to a set direction with a set amount of visibility, so they're kind of like a cone of light. And nothing more. An omni light, on the other hand, is, well, omni is the key word there, all directions. Think of this like a lamp. An omni light still has range. It still falls off, so it's not like as omni as like omnipotent, for example, but it does go in every single direction. A direct example of an omni light would be a lamp with no shade. So if you take a lamp and it's just there, a light bulb, or even a roof light with no shade, so there's nothing directing or shaping where that light goes. It's just a light that goes in all directions until the strength of it falls off. That is your omni light. Now finally, you have a directional light. That's what we're going to use today because it's probably the least easily explained, but it's still a very simple concept. An omni light is a light and a direction, and it's just so like with a spotlight, it generates at a specific point and radiates out, whereas a directional light is just from one direction to the other, 100% kaboom. And where you could, the most direct parallel you can think of to a directional light is your sun. And this is basically a light that kind of doesn't have a source, or because it's just so big, and it doesn't really have a focal point. It just has a direction, and we'll go ahead and create one right now. So this is like, again, like your sun, and I will add this directional light to the scene, and you'll see it created this big arrow, 3D wireframe arrow. Now we're just going to go ahead and position it. So first we'll pull it back behind our camera and up a bit, like so. And now I'm just going to go ahead and rotate that so it's pointing down at our cube, like so. Let's move it back a little bit more. So this is just basically a big light, and everything from this direction goes and lights everything from this direction. It's a very intense light. Now, if you look down here under your inspector, you can also see there's a couple of settings available for it. Now, a lot of it we're going to go way beyond. First off, this is controlling how shadows are generated, or if they are generated. We can actually turn shadows on or off. There's an expensive thing, so if you don't want shadows generated behind the light, so this light causing a shadow to form in behind here, for example, if you don't want that on, it creates a lot of processing requirements there, so do be aware of that. But you can control how shadows are generated here. Again, a little bit beyond what we're going to talk about, but there's also the light settings here. And the light settings can be done for, you turn the light on and off, obviously. And now at this point, this is also, now that you have lights in your scene, it's probably worthwhile to turn off the default lights. So then now you're dealing with just the actual physical lights in your scene, not the lights that are added for the editor, because those editor lights will not show up when you run your game. So that's what this makes this default lighting important or not important. So we're going to turn that off. So now you can see just the effect of this big directional light running, and you can change the color of said light. You can have the light come out of another entity, or let's see what else is important here. There, your energy, which is basically a number representing the strength of said light. So if I go to very weak light, very strong light. So those are the primary values you will use in for the lighting. But now we have all of this in. We've essentially just created our first 3D game. So you can see here, you've got your base is your node. You've got just a test cube thrown in. Eventually this will be a model, which we'll deal with again next tutorial. You have a camera so you can capture everything, and you have a directional light. Now, one thing I didn't cover, flipping back to the camera for a second, you can actually have multiple cameras in the scene, and if you do, make sure you set current as on for one of them, and that will determine which camera is actually used when the game is run. So if you want to switch between cameras, you can encode quite easily, and the value that determines it is this Boolean for current. So we have a cube, a camera, and a directional light, all slave to our node, and we'll just go ahead and run this, and there you go. So congratulations, you just created your first 3D application in Godot. Stay tuned for the next portion, and we're going to again look at animation, importing 3D models, importing static models, applying texture to static models, and animation. So between these two, it should get you a good start in working with 3D, and then we will explore further concepts from there. I hope you enjoyed that. Once again, there is a text-based version of this available on Gamefromscratch.com. The entire series homepage is available on Gamefromscratch.com. To do a small plug-in here, if you do enjoy this type of content, there's also a Patreon page on Game From Scratch. Your support is definitely appreciated. However, having all of you watch these videos is also appreciation enough. So thank you very much. See you very soon. Cheers.